Okay, still in section 3.3, discussing some nice differentiation rules so we don't have to always use the definition of the derivative with the limit. We got these rules. So the next one, this is a really important one, the derivative quotient rule. It's called the quotient rule. Quotient rule means if I have a function divided by a function, right? U divided by V. The last example, we had the product rule, U times V. Well, this is U divided by V. Okay, so it's this formula, and I don't ever memorize it this way, v to u dx minus u dv dx over v squared. I actually use this little memory device, right? This little memory device right here I wrote in quotes. It's low d high minus high d low over low low, or some people will say low squared, right? So it's the low function, v, times the derivative of the high function, du dx, right? Low d high minus high d low. So what I mean by low is the denominator, and high I mean the numerator, right? So low d high minus high d low over low low, or low squared. So there's really only two derivatives I have to take, the derivative of the high and the derivative of the low, or the derivative of the numerator and the derivative of the denominator, but this is the way. Some people will see it as f of x divided by g of x, so it's g times f prime minus f times g prime over g squared. But again, if you think of it as low d high minus high d low over low low, sounds like the seven dwarfs, but it's just a nice way to memorize the rule. It's really important. The order here is important. Most of the rules we've had a plus sign here, and the order wouldn't be important. But this is important that you do low d high first, and you subtract high d low. So low d high minus high d low over low low. Okay, this is the formula, or this is the formula, however you want to look at it. So let's do an example. The proof is slightly more complicated than the proof of the product rule, so go ahead and take a look through it. Again, I would not ask you to be able to reproduce that, but I want you to understand that this proves that the derivative of a function divided by a function will always be this. Okay, so we don't have to ever worry about the fact that this is not true in some cases. It's always true. All right, so in example 34, let's say we have y equals t squared minus 1 divided by t cubed plus 1. So we have a function divided by a function. We got the high divided by the low, right? High divided by the low. So it's low, t cubed plus 1, d high, the derivative of, in our variable here is t, the derivative with respect to t of t squared minus 1, minus low d high minus high t squared minus 1 d low, the derivative with respect to t of t cubed plus 1, over low low, or low squared. Low d high minus high d low over low low. Then you just take the two derivatives you need. So the derivative with respect to t is 2t, put that here. The derivative with respect to t of t cubed plus 1 is 3t squared, put that here. Then you can multiply these out and simplify as much as you want. Okay, and then I would just leave it like that. Now notice in something like this, what I have here is I have a top function, right, divided by a bottom function, high divided by low. So I could start to apply the quotient rule. Now within the quotient rule, so I'm going to go low d high. Notice that in this case I would either need to multiply these out or apply the product rule to get the derivative of the top here. Low d high minus high d low. And then I want you to always think, so this example I threw in there because I want you to always think this is a little bit more complicated than necessary, because I could have just distributed and multiplied this guy out by foiling it first and then simplifying the function. So notice that if I FOIL this guy, we got x cubed, I would get a minus x squared and a minus 2x squared would give me minus 3x squared, and then I get plus 2x. So that's the numerator divided by x to the fourth. Now, if I have an addition of things in the numerator divided by a denominator, I can take the first guy divided by the denominator plus the second guy divided by the denominator plus the third guy divided by the denominator. So x cubed divided by x to the fourth is 1 over x, which is x to the minus 1. Then minus 3 times x squared over x to the fourth is minus 3 over x squared, which is the same as minus 3 times x to the minus 2. And then 2x divided by x to the fourth is 2 over x cubed, which is the same as 2 times x to the minus 3. And now I just have three simple power rules, right? If I want the derivative of that now, I haven't done anything with it. I just simplified this guy into this guy. Now I take the derivative of that by just using the power rule 3 times. So minus 1 times x to the minus 1 is minus 2. Minus 2 times minus 3 is positive 6 times x to the minus 2 minus 1 is minus 3. Minus 3 times 2 is negative 6 times x to the minus 3 minus 1 is minus 4. And then if I don't like the negative exponents anymore, I can rewrite this as minus 1 over x squared plus 6 over x cubed minus 6 over x to the 4th.